In 2016, Bell Engineering entered initial discussions with Darkham Engineering on the potential machining of a PFCS waste bin for Sellafield. These discussions culminated in 2017 with Darkham placing machining orders for all parts relating to the PFCS waste bin. Since then, Bell Engineering have been machining a combination of both the PFCS and the MSSS variants of waste bin to a high quality level for Sellafield. We have striven to improve the machining process. However, late in 2017, we recognised that only a certain amount of improvements could be made using conventional machinery and conventional fixturing. Whenever we tried to improve productivity, we came across chatter within the process. So in December 2017, we engaged with Kingsbury Machine Tools in a collaborative effort to design and manufacture an entirely new concept in both work holding and machining for both variants. With the ambition to improve cycle time and therefore rate and cost, both businesses have subsequently invested around £500,000 in searching for the optimal solution. Since that time, Bell Engineering and Kingsbury's have worked constantly to design and innovate an entirely new solution, with this culminating in December 2019, where I witnessed the trials of machining of an MSSS box on an entirely new patented solution. This solution will save cost and will assist Sellafield to hit rate of boxes as extractions ramp up over the coming years. I hope you enjoy this short film explaining the advantages of this solution.
In March 2018, we embarked on a research project that sought to establish the most cost-effective method of manufacture for a nuclear waste container. At every point on this journey, the solutions realized were predicated by the unavoidable and intrinsic fact that vibration is the enemy of machining. Given the nature of the material, is duplex stainless steel, and the properties of the part itself, every conceivable source of vibration has been considered, from the machine bed to the column, the guideways themselves, the spindle tool interface, the cutting tools used, their grade, their geometry, and a forensic analysis of how the part itself is being held. Doing the maths and working within the laws of physics dictated the direction taken. And this video book seeks to depict that journey. A journey that culminated in successful cutting trials undertaken in Coburg in Germany late last year and early this year, and the issuing of an important industrial patent. Tap testing, or modal testing, is a non-destructive process commonly used within industry where limiting vibration is an essential part of protecting the integrity of a part or a structure. It can be used across a broad spectrum, from some machine tools would use it, aerospace components, the chassis of a motor car, even civil structures like bridges. It is resonance that we're interested in, as this is the real killer. It can lead to the amplification of vibration and ultimately the destruction of structures themselves. The wind effect on the Tacoma Narrows Bridge is a classic example of how resonance can do its damage. When it comes to machining, any resonance that occurs due to poor fixturing or the lack of structural stiffness in the machine itself leads to chatter and inaccuracies. Chatter reduces tool life as the cutting inserts are not machining at a constant force or depth, which inevitably leads to a deterioration in productivity. To understand the natural frequencies of the MSSS box, it was examined in 3 different conditions, each referred to as a degree of freedom. In each of these 3 states, modal analysis was conducted in 12 different but repeatable locations around the fabrication. The first set of tests were completed with the box in a free state, resting on 3 stands, representative of how it would sit within the fixture. This was done to get a clear idea of the box's inherent resonant frequency before any external influence has been applied. The second set of tests were completed with the box hydraulically clamped in the fixture. This meant that all 32 touch clamps, 3 push clamps, and 12 swing clamps were engaged. These tests were completed to give an idea of how much vibration there would be within the part if only conventional clamping processes were employed. The third set of tests were completed with the box hydraulically clamped, as in step 2, but with all external and internal airbags engaged also. The following tables show the time taken for each of the inputs to reach a point where the amplitude remained below 0.1 G. The overall reduction in time for the assembly to return to a steady state, i.e. below 0.1 G, was up to 150 times quicker with all clamping features engaged, with an average time of less than 0.02 of a second measured. The high degree of dampening limits the build-up of vibrations during the machining process. When considering the action of milling, each individual tool tip represents a strike. Closer analysis of the feeds and speeds of one of the tool paths clearly explains the benefits that the dampening effect induces. If we imagine a cutter that is rotating at a speed of 176 RPM that contains 8 individual cutting teeth, the maths is relatively simple to work out. 176 times 8 divided by 60 gives me the number of taps per second, in this case 23.466 taps per second. If I work that out in terms of time, that's 1 second divided by 23.466 equates to a gap in the strikes of 0.04 of a second. In this case, when looking at the dampening properties, the agitation induced in the material through the cutting process has completely dissipated in the elapsed time between the striking of the first and second tooth, an outcome that is impossible to achieve under conventional clamping conditions. That said, the greatest fixture technology in the world will be as nothing without the right machine tool to hold it. The machine is built on a large cast iron base and incorporates a static column and moving table. This configuration lowers the machine's center of gravity whilst moving mass and increases stability. The ram constitutes a large section, 400mm by 400mm, and provides the rigidity needed when machining the lower part of the box at the maximum extension. Each axis of movement is supported by a hydrostatic guideway. The principle of the hydrostatic guideway is the pressing of an oil film between the slide and the moving assembly. Irrespective of speed and the applied load, the distance between the faces remains a constant. Baldric Coburg's unique pump-per-pocket hydrostatic system ensures that an unchanging volume of oil is distributed. This means that even whilst machining with long ram extensions or heavy cutting conditions, the pump-per-pocket system maintains the oil gap between the guiding elements, and any vibration caused through the cutting action itself cannot be transmitted. The spindle employs a large bearing pack and an HSK 125B tool interface, providing superb rigidity and machining capability. When machining this material at the levels of performance achieved, it is essential that each of these elements are present. Duplex stainless will seek out any weaknesses in the machine tool. Once rigidity of the machine is achieved, we must turn our attention to the fixture.
Around the front of the fixture, you've got 12 swing clamps. These swing clamps are located and connected to the machine, so as the cutter moves around the front of the machine, the swing clamps move into position and move out of position. So at any machining time, you've got 11 clamps in contact with the job. And with the combination of the vibration suppression of the airbags, the job stays very rigid and stays in the same place. You can see a big steel plate that's sitting inside of the box. Behind that are 5 airbags, one round each face and one at the back. In the fixture itself, there's also 5 airbags, again 4 around the outside of the box and one at the back. We've used the airbags, both internal and external, to apply an opposite and equal force, which reduces the vibration in the 6mm walls.
The combination of the superbly configured Taurus 30 from Valdrik Coburg and a fixture design that alters the resonant frequency to such an extent that it has similar properties to a solid cube of metal eliminates the need for compromise in the machining process. Listen to the actual sound recordings of the various cutting processes. Evidence of processes that are in complete control. It is this combination of fixture design and machine tool platform that allows these dramatic productivity advantages to be realized. It's important to note the solution developed for the MSSS box applies equally to both the MSSS skip and the PFCS box, each of which will be held in their own fixture, complete with bespoke internal and external airbag assemblies. Having detailed machine platform and fixture methodology, it is important to explain the automation provision within the Taurus solution. We have designed 2 fixture assemblies that are capable of holding 6 different part variants. In this case, the MSSS and PFCS boxes, the MSSS skip, and as we rotate the pallet around, we can see the MSSS and PFCS box lids, both A and B sides, on the rear part of the fixture assembly. The second pallet, pallet B, will house the PFCS box top rim, side A, and the MSSS box top rim, side B, both in the pre-weld condition, as well as the MSSS skip lids, both sides A and B, in the post-weld condition. Once again, as the pallet rotates around, at the rear of the pallet, we can see the MSSS box top rim, side A, and the PFCX box top rim, side B. Once again, both in the pre-weld condition. In short, we have a complete ship set of all parts needed for both the MSSS and PFCS variants across the 2 installed pallets. Whilst one pallet is located within the machining area, the operator has free access to unload and then reload to the now empty fixture assemblies on the second pallet. Downtime is now limited to the pallet change itself.
Combining Kingsbury's patented fixture solution along with the Valdrik Coburg Taurus machine, I know will provide Sellafield with a reliable and cost-effective long-term solution for the manufacture of PFCS and MSSS boxes. I hope this film has been informative and would like to thank Kingsbury on their collaboration in the development and design of this innovative solution.